The thing that really struck me about Bitcoin and Ethereum is you read this code, what it's trying to do is all about this notion of assets and exchange. But these languages have no primitives for assets and no primitives for exchange. Someone did something wrong because they were trying to do something complicated that should have been simple if you were starting from the right building blocks.
Sam Blackshear, co-founder and CTO of Mysten Labs.
The team behind Sui. He created the Move language at Meta.
And is now making it easier to build in Web3.
How did you get so fascinated by the world of cryptocurrency?
I did this static analysis developer at Facebook for a number of years. I love the work. I got pulled into a room by the senior tech lead at Facebook. He told me about this Libra Facebook was working on. It's this very, very big vision, but I never really thought about that's a problem that I should work on because Facebook didn't have any code in that area.
What is the Sui Network, if you had to explain it to your mom?
The Sui Network is an experimental developer platform. Think of the iOS App Store in the early days when people didn't know what to do with mobile apps, so they built an app that you press a button and it farts or something. That's the stage we're at. There's really a lot of potential here in terms of the problems that can solve.
You're the creator of the Move language. How would you explain the Move language in one sentence?
It's a language for programming with money.
How do you come up with a great idea?
Great ideas are great because they solve important problems.
What are the main problems to solve?
So with Move, I actually did want to really start off with having a clear set of problems to solve. And so those problems were, you want a representation of money or of things that are inherently scarce.
How do you get 5x more developers in the crypto space and move them, pun intended, to the Move language?
69% of the people who watch this podcast have not subscribed. If you enjoy this show, if it provides value to you in one way, shape, or form, can I please ask you a little favor? Can you click that subscribe button, give this video a like, and leave a comment down below? It helps this show more than you can imagine. My goal is to bring the absolute biggest and brightest people on this channel, and the best way to get there is to have all of us rally together and build the When Shift Happens family. Thank you. This conversation is supported by Jupiter, the most used decentralized trading platform on Solana and the largest DAO in the world. Bitwise Asset Management, the crypto specialist asset manager with more than $10 billion in client assets and more than 30 crypto solutions across ETFs, index funds, alpha strategies, staking, and more. Sui, a scalable layer 1 blockchain that's fast, secure, and affordable, built by previous Facebook developers, and that delivers the benefits of Web3 with the ease of Web 2. And Mental, an Ethereum layer 2 that built two products I particularly like. FBTC, which enables you to borrow and lend Bitcoin in DeFi, and METH or METH, one of the largest ETH liquid staking protocols in crypto. To support this show, please check the sponsors links in the description down below.
In general, if you start in a field, you can get that's what I'm doing. I'm looking at Lex Friedman. I'm like, okay, who was his guest number 20, 25, 30, right. 50? And he had Elon Musk,
sure,
maybe 35, right? But it's a lot of, strategy, everything, right?
Yeah, for sure.
It's okay, I'm from MIT, and how long do you have the guests for? That's also a big thing. Elon Musk first time, 30 minutes, right?
Yeah.
That when you start to get to a certain level, it's when people say, I'm going to stay for an hour and a half, 2 hours, 3 hours, right?
Yeah.
They really want to spend the time. But you can really go within, 50 to 100 episodes, you can really go to places you thought were not possible.
Yeah. Do you listen to Dwarkesh podcast?
No.
This guy, it's a 22-year-old kid who, is now having Sam Altman and Satya Nadella and stuff like that on there. It probably also an interesting arc where I guess his thing is he's just, they say this way more prepared than everyone else. I feel I have trouble believing that's
to be honest.
Yeah.
For me, you said before, right?
Yeah.
Oh, you come with the notes.
Yeah.
Right, on paper. That's also my strategy.
Yeah.
If I prepare a lot and we do have a very different conversation, first it's in studio, which is very different in crypto. Yeah. Most people don't do it in studio, right? For me, it's every week in studio. Second, you have very different conversation than this very nerdy conversation, and you show respect by preparing, and you're going to see that in the questions. Then the guest likes you.
Yeah.
And then
right. Makes sense.
And then the whole production quality, obviously, we do trailers, all that stuff. Is it different? Or fuck, this is not just a podcast that's released once. There is multiple pieces of content.
It's
actually good quality.
Totally, yeah.
And then you kind of play on the ego of the person. They're oh man, this guy respects my time and respects me.
Exactly. Okay.
I'm going to introduce him to someone else because I'm not going to look bad, right? It's going to make me feel actually, it might even make me look good if I introduce him to someone else.
Right.
And that's how you can get...
Yeah. Someone else that I want to promote because I know he's going to make them look good. Yeah.
Absolutely.
An ecosystem project for
Absolutely.
Yeah.
Absolutely.
Yeah. That strategy makes sense. Versus showing up and shooting the bull, which people did for years.
It's basically networking on steroids.
Yeah.
That's how a 22 years old could get to...
Yeah.
Sam Altman or Satya, and like, okay, like this guy has something a bit different, and he's probably very good at. If I want to get this guy, maybe if I get this guy before, and I do a really good job, then he's gonna introduce me, right?
Yeah, right. Being deliberate with the selection, huh? That's super interesting.
I mean, we all need to have a little strategy to get to where we want. And for me today, it was to have the honor to use for the very first time the Mysten Labs podcast studio that was never used before.
That's what we're both trying to get to. We've achieved the goal just by sitting here. So, everything else is just a bonus, right?
How are you doing, Sam?
I'm doing pretty well, and you?
Very good, very good. Spent 2 weeks here just recording with everyone, and I have another 3 weeks. And as you said before, like we did this COVID test, I'm just trying to not get sick.
Yeah.
Because for me, you said no one has that time, right? But for me, I have to fly from Singapore, where I live, 20 hours, 16 hours time difference. So I'm destroyed for a few days.
Yeah.
I'm like, I need to make it worth it, right? And then I was always thinking, if I get sick, which is what happens to a lot of people now, 3-4 weeks, my whole trip is fucked. And my whole podcast is fucked because I need to deliver, right? Every week.
Yeah, right.
And the sponsors pay for like it's a business, right? It's consistency and discipline.
Yeah, that's true. Especially when the trip's a limited time. Yeah, you can't afford to be sick any time, especially like you have 4 weeks here, 6 weeks here, or whatever. And yeah, you've got it lined up with visits the whole time. And
absolutely. If you had to summarize what it is you do and why you do it, what would you say?
Yeah, so I would say, I'm working on an experimental developer platform along with everyone else in Mysten Labs and in the Sui community. So my job, what I do is I work both on improving the technical design of the developer platform, improving the way that folks consume it, and then working with the people who are building on it or want to build on it to see what they need from it, how they're using what's there, what they might need next, what's blocking them, what's painful for them, and then go back to the Mysten engineering team, the design team, the product team, and work on incorporating that feedback and sort of trying to both do the tactical bits of addressing the immediate pain points versus, more long-term design things, figuring out what are they going to need in 6 months and 2 years, like, what are the things that would really supercharge what you can do with Sui or what you can do with the value proposition of a crypto-powered platform, what you can do with Walrus. So that's the what. And then the why is, I've always been really interested in software and programming. My whole career has been around writing safe code, but, having the right ways to capture the thing you're trying to do, the most efficient ways, the most direct ways, clear thought, translating directly into software that, looks like the thoughts are sort of, with tools that are helping you to think better and to do your job better instead of that you're fighting with. I've just always found that very interesting. And so building a new kind of developer platform is sort of the ultimate form of that, because you really are you get to do it all from scratch and you get to make things your way and you get to learn a lot. The experimental aspect of it is really, I think, my favorite part, being surprised by what people build.
Who are you?
Yeah, that's a big question, a big blank slate question. So, I'm someone who gets really, really interested in things, and then, they start by dipping a toe in, maybe without a lot of intentionality, and just like following their interest and sort of seeing what happens, and then like maybe somewhere in the middle or early on end up having a little bit more of, okay, like what am I doing in this experiment? Is this something I want to keep doing? What are the goals that I'm aiming toward? Maybe I should do something else or try. And then like, after having the initial interest, like going for it. I think that's the kind of person I am, and sort of how I got involved in this whole crypto thing, starting from a background of being an academic and being a researcher and being someone who works on programming languages. So yeah, I think that's who I am, is someone who's driven by interest. And then like, once I've gotten pulled in, like maybe takes a step back and adds some intentionality.
What do you need to be thinking, okay, out of all these things I'm tipping my toe into, this is the one that I want to pursue for the next couple of years?
So for me, it's always a mix of sort of like passion and intellectual interest, and along with impact. I mean, I think there's so many things that anyone can do with their time and with the talents that they have. And so I think, you obviously want to be doing something that you enjoy and that you find fascinating. And for me, I'm very curious. So I think like, there's, if I lived 100 lives, there's probably 100 different things that I would do. But then it's also, you only get to live once. So you want to be doing something that's both interesting and that you feel like is going to make a difference, or you feel like is going to make the best use of those things. And so that's how I sort of evaluate it. I mean, it's both on like the macro scale in terms of what I choose to do with my career, and the micro scale in terms of, what am I going to do with my day? Both like thinking about that impact aspect and the like personally energizing, personally interesting aspect.
Dear When Shift Happens family, the following message is probably the single most important thing you should take away from today's podcast. If you're serious about your crypto investing journey, please take some time to learn how to self-custody your assets to make sure that nobody can take your coins away. Ever. If you don't learn how to be your own bank, it is very likely that one day you will lose all your hard-earned crypto. The safest way to hold your crypto is in a cold storage that we also call hardware wallet. Hardware wallets are not complicated and they give you peace of mind. I personally use a hardware wallet called Trezor. It is open source, very easy to use, and the first hardware wallet created ever. As we like to say it in crypto, not your keys, not your coin. You can order your Trezor wallet with a 10% discount by following the link in the description down below and by using the promo code WSH10. And now, back to the episode.
You said if I lived 100 lives, right? I might be doing some other things. If you were living a second life, what else would you be doing?
Just one more. So, I think AI and developer tools is a really interesting space. I mean, like obviously AI is transforming the way that we write software. But I think like doing this well, and especially doing it in a way that's safe and that's sane and that magnifies productivity without like creating issues with security, issues with maintainability, the same sort of things I grapple with in a different context in the crypto space is just like a very interesting and relevant problem. And I think a lot of my background would like have something to say about that as well. And it's just, it's a very different kind of space, like combining this black box that's very smart but very non-deterministic versus like the stuff I do, which is having a black box that's maybe not as smart but is like very predictable and very has a lot of structure in what you can specify and say about the inputs and outputs. So I mean, certainly I get to dabble with that a little bit in what I do, but in like terms of like living a completely different life, I think that would be an interesting area to work on.
Where does this crazy fire in the belly come from?
I've just always had a lot of energy, and I've always been really curious. I grew up in an environment where my parents just really encouraged me to like do things that are interesting to me, and like whatever I wanted to do, they were like behind it, whether it's something that they particularly liked or not. Like I got into skateboarding, and they were like, I'm sure they weren't very happy because like this is a silly thing to do in a way you could get hurt and like sort of vagrancy or whatever. But they're like, fine, we'll build a ramp for you in the yard, and
Oh, nice.
and take you to the hospital when you break your ankle and stuff like that. So I think I give them a lot of credit for just like pushing me to pursue my interests and supporting me, and then I've just tried to take advantage of that kind of support, and the support that my network of co-founders, friends, collaborators have been there with me for my whole life. Besides that,
it's small things like that, right? But you talk about skateboarding and your parents being supportive, and by showing actually, let's build something in the backyard for you. I remember for me, I was 16 years old, and I was like, I want to become a DJ out of the
nice.
Right? It was before like this big trend of like DJs. Which is not a trend anymore now.
Yeah, like you had physical CDs and like a big binder of like 500 CDs. Is that kind of?
We had like it was not vinyls. Like it was just like it was the CDs exactly.
Yeah.
In this Pioneer. I forgot CDG 800, CDG 100.
Sure.
And so, but I wanted to do that because I had seen at a sort of like a village party like a friend of mine who was able to capture people's attention. I was like, this is amazing, right?
Yeah.
Just with music. And so I go home, but I was feeling ashamed. I was like, this is weird. Like, it's nighttime thing. And I'm like, I'm studying. I was playing a lot of tennis back then.
Yeah.
And I was like, this is completely different, right? So I was like, but I just went to my parents. I was like, I want to be the DJ. And I was like, and then my dad he comes and he sits down with me and he takes a piece of paper and and he starts to just draw down a mind map. And he's like, okay, what's your goal?
Yeah.
I was like, what? Like, what's your goal? Like, okay, I was 16 or 15 and a half. I was like, okay, I'm too young to play in big clubs, right? I need to be 18. When I'm 18, I want to play in this Swiss football stadium. They have like a 5,000 people club. And then he started to like draw a mind map.
Yeah.
Like super supportive. He was like, yes, so then you need good material. How are you going to get this material? Oh, I'm going to go work on construction fields, etc. And I was like, actually the same, right? They come and they're very supportive. And then you go from like, oh, I'm kind of ashamed of like thinking about that to like, fuck, like if I have a bit of support, it could make a massive difference in your self-confidence and what you can achieve afterwards. And probably all these accumulation of all these small supports, like then like just helps you a lot when you start a business or something that it doesn't seem that it's too big anymore.
Yeah. I mean, I love that story. It's like, yeah, what a great way to provide support. It's like, let's build a framework and like, put some adult level planning and thought into this, which will, maybe help you achieve your goal or maybe make you see that your goal is different. But, either way, it's like, just the honoring that interest and that passion that you had. I love it. And you're right. These things add up and they give you the courage to like take chances and try stuff.
You said you had full support of your parents for a lot of things. And you also told me the other day when we talked that you didn't care much about math and science. You loved writing and doing a ton of sports.
Yeah. Yeah. So I think definitely a lot of, I'd say sports are like, my main like interest or passion, the thing that I hope to do growing up. I very much wanted to be and thought I was going to be an NBA player right up until the moment that I was cut from my middle school basketball team. And then beyond that, I got into running. And so I did cross country and track and, it's all about like trying to perform really well. We had a super competitive team and we pushed each other a lot. And I wanted to run in college, ended up being able to do that. But yeah, just a lot of my childhood spent like trying to be good at sports because I don't know, it's so quantitative and it's so like direct to see that you're winning or doing well or improving. Whereas like doing well in school, like you can do well and like I did, but it's it's not like you can be the best. You can be the best runner on your team, or you can be the best basketball player on the team, or not in my case, but one could be.
What happened with the basketball?
Things.
Because you're super tall.
Yeah.
How tall are you?
I'm 6'4", and so I was that tall back then too, but I probably weighed about 150 pounds. So I played this weird kind of a position where it's like the big man or the power forward that like runs the floor, but like can't box anybody out or rebound. So I think I actually had some skills, but it was a very unorthodox kind of player. Maybe if Kevin Durant had been around, had been like a popular NBA star at the time. I was playing, the people would have been more receptive to my position. But yeah, I think I was too light for my height and not strong enough and just not that skilled with the ball, unfortunately. I still play for fun.
So you said, hey, I want to do a lot of sport and I want to become a writer.
Yeah, or I liked writing for being able to, not being an author per se, but like a way to, when you sit down, you have an idea and you sit down to write something down, you think you understand it, and you always realize, you don't understand it as well, and you have to revise. And sort of like this aspect of telling a story or explaining something and using writing to clarify your thought is always something that I really liked from the beginning. I think the school I went to was very good at that, like forcing you to revise something a ton of times, like put your argument together in a really tight way, make sure it fits together, there's not these leaks. That was something that inspired me from an early age, and I still care a lot about clear and excellent written communication.
What made you change your mind on what to study?
Yeah, so I think it was really and I took science and math classes in high school, and I think I did okay with it. But I got to college, and the school I went to has the highest percentage of math majors of any school in the US, I think. And it's because like they have a crazy good math faculty who are just, I don't know how to describe it. I think math can be very dry, but they like really, I think, get people excited about math and liven things up and sort of show the applicability of things. And so like I really got pulled in via that. And then as part of that, I took a computer science course, and then I was like, oh, this is like math, but the thing that's hard about math is that you are writing some stuff out, but you really have to know all the rules to know whether you're doing it right. And if in computer science, if you're programming, you have this aid of like the compiler, the interpreter, running it, whatever, you can like get this very immediate feedback of like, is the thing I did right or not? And like, incremental progress of, okay, it's like not quite right, but it's getting closer, or like understanding it. And so I just got really hooked on that. It's like all the rigor of math with a faster feedback loop. And then you can build something that's like not a theorem, but like, it's an application that's, telling jokes or printing something cool to the screen. And so I sort of got into it that way, just the feeding off these really excellent educators in math, and then being like, how do you take that interest and turn it into something where I like the end product better?
And then you did a PhD in language programming.
Yeah, in programming languages and program analysis. So, programming languages is, the study of creating and analyzing the things that we as humans use to interface with the computer. And then in program analysis, it's all about trying to look at programs and then understand them and oftentimes prove things about them. So like there's this famous halting problem result, which is like, you can't in general come up with a program that can look at another computer program and say, oh, this is going to terminate or it's not going to terminate. And then there's this result called Rice's theorem, which is a generalization of the halting problem that says like, if there's any non-trivial property of a program, like anything that's true of some programs and not true of others, then you also can't like write a program that will determine that with full fidelity all the time for any program. And so in program analysis, what we're trying to do is defy the gods, defy those theorems, and try to provide this result sometimes, but not all the time. And you do this via this technique called overapproximation. So the idea is like, the properties we usually care about is like, does this program have a bug or not, for example? So what you can say, the observation with overapproximation is you can say, well, I can give you a guarantee that if the program has a bug, I will find it, but I might also lie and tell you there are bugs when there aren't bugs. So a trivial overapproximator said, does the program have a bug? Return true. Yes, it has a bug. Great. I'll always be able to find it. And then it's like, okay, but can I do better? Now I actually look at the program text and I can prove that there aren't bugs, but then maybe like be imprecise and get confused and say that there aren't in other cases. And then just try to do this for like more and more complicated things and with more and more precision. That's sort of what program analysis and my PhD and research field are about.
How did you feel while doing that?
Oh, I mean, it felt amazing. This defy the gods. I really do feel that way. It's this incredibly cool thing where like it's a task where like it's impossible by construction, but there's no result on like how close you can get to perfection without actually getting there all the way. And when you have program analysis tools that work well, it's just like magic. They can look at this enormous system and tell you these things that you thought were impossible to find or that other people thought, and it's something where the science is early and not well established, and definitely like the industrial practice is even less well established. So it really felt like if you made progress in this, like you might really be changing the way we write software, the precedence of vulnerabilities and bugs and hacks in the real world, and that there's just like some real potential here. So I found it to be very, very exciting. I still find it to be very, very exciting.
You wanted to become a professor. Why?
And this is the typical route for someone who's doing a PhD. PhD is a long time investment, right? It's like 5 or 7 years to acquire a very, very specialized skill or set of skills. Like I think usually if you want to work at a company or do something else, like the quicker path is like you should just go to that company and take whatever job you can and work your way into doing whatever you think you should be doing. But for me, I told the story about myself in college. Like this thing with computer science, I started it very late. Like I started in my junior year and just like barely finished enough classes to do the major. So I felt like, I wasn't done learning. And so like I thought of the PhD as a way to continue exploring computer science and to keep learning. And then it just so happened that, the thing that you usually do after you keep doing all that learning is that you become a professor. And so, and as a PhD student, you write academic papers, you go to conferences, you learn how to be a researcher, and then you become a professor and train other researchers and, run your own lab. But there are also, industrial positions, but it's just like that's sort of the default thing to do. So that was the path I was on. And, I had these great educators in my college, and, I thought it would be great to teach computer science as well and be a professor. So yeah, that's initially what I wanted to do.
And then you did this internship that changed everything at Facebook.
That changed everything. Yeah, exactly. So the internship was actually preceded by something else that changed my life in a funny way, which is, as a PhD student, you're always trying to get funding. Like your advisor gets funding and they have to fund you, but they're trying to get you to apply for fellowships so that they don't have to fund you. The fellowship will fund you. And so my advisor is trying to get me to apply for the Facebook fellowship. But I was I was very busy and I didn't apply, and I was on vacation in New Zealand, and my professor bugged me. As like, "Hey, you need to write this fellowship." I was like, "But I'm on vacation." He's like, "Well, you need to do it anyway." And so, I took a day out of my vacation in New Zealand to like put together this fellowship application and sent it in. And I was like, I did it on vacation, maybe not with full attention. I wasn't sure anything would come of it. But then I ended up winning this fellowship, which came with an internship attached. And so like just, that one day of like listening to the good advice from my professor and doing that, like led to the internship at Facebook and then the job at Facebook and then to Libra and to Mysten. It sort of like changed everything. So yeah, that internship, so it was great to get the fellowship and a real feather in my cap, but the people I got to work with there and the work experiences what really changed my point of view where, this program analysis stuff, like we wrote a lot of papers, we wrote a lot of tools and looked at open source software, but it's very hard to get people to care about it. Like you can find bugs in open source code and like maybe fix a couple of things and, they're happy, but there's not really a way to scale out that effort. But at Facebook, it was, you took the same technology and then you put it in the developer workflow. And now like thousands of programmers are seeing it a day and, it's finding hundreds of bugs and they're saying, it's awesome that you found this. I'm very excited. Or like, why didn't you find this? Like, I'm very upset here. Please improve it in this way. It's really like interactive. You get this feedback. It's a super like addictive and sort of like, fast progress kind of environment because, now people are really using your stuff. And so it was the same kind of work I love doing, but, having a lot more impact and getting more feedback. So I was totally hooked on that. After the internship, I only had a little bit of PhD to do. So I finished that up and then joined at Facebook as like, let's take this thing that, I had loved doing because I felt like it could have so much potential. And Facebook was one of the first companies to take this technology and like really give it a serious effort of making it work in production. And so it was just super exciting to be a part of that and seeing, this become a part of how people write code, which is still true at Facebook today and true at more companies after Facebook pioneered it.
When you said this technology, what do you mean exactly?
Yeah, so I mean static analysis or these tools that look at programs and find bugs like crash bugs, like security vulnerabilities, like SQL injection or shell injection. It's just you have some class of bugs or vulnerabilities you're looking for. Maybe it's a null to reference, race conditions, SQL injection as mentioned. And then usually the way these things work is you turn them on in your CI. So when you check in your code before it actually lands, this will run and say, just like a supercharged version of the compiler, hey, I think there's a null to reference at line 27. Here's the path that leads to it. And then you get this extra signal on things that you could do wrong and you can fix it. And then instead of learning about that bug when a user finds it in 2 weeks and then, getting some egg on your face, you find out about it. You find out about it earlier and you can fix it and the code's just safer.
So when you joined Facebook, you started to do all these very more practical things. How much of the things that you did in the PhD was really useful?
So a very high percentage of them, which is why I enjoyed it so much because like we built the same kind of tools. It's just that it was hard to find the users for them. And we had to do a lot more of like the infrastructure stuff of like trying to build the code that we're finding bugs in even, or like find the right examples to look for. And here it's like, here's your examples, the millions of lines of code that Facebook has. We already have build systems, we already have CI. Like you get to focus on just the part that's the hard engineering and science that's specifically related to program analysis and this automated bug finding thing.
So you like that so much that you said, okay, I'm going to go back, finish my internship, my PhD, and then move back to Facebook.
Yeah, exactly. It's like, being a professor would be cool, but it feels like this is, the industry is changing. It's sort of adopting this research technology. They're trying to commercialize it. Like I want to be a part of that. And I love working with them. The team that I worked with at Facebook was a team of academics who had a startup that was acquired by Facebook. So, I think we all thought a lot the same way. We had similar academic backgrounds and similar ambitions for what this technology could do. So it was really awesome to work with work with like-minded people, but then also with crazy Facebook programmers and industrialists, like just a very productive mixing of different points of view and expertise.
How did you get so fascinated by the world of cryptocurrency?
Yeah, that was a very interesting path into that one. So, I did this static analysis developer info bug finding stuff at Facebook for a number of years, like 2015 to 2018. And I loved the work and I had no intention of doing anything else. And then I got pulled into a room by Ben Maurer, who is the senior tech lead at Facebook, very legendary figure there. And he told me about this Libra thing that Facebook was working on. So it was about this blockchain-powered global payments network. We're going to use it to do currency. We're going to use it to do payments across borders. We're going to have a stable coin. It was this very, very big vision, and also this sort of like secret and like very ambitious project where Facebook usually does more like internally public and incremental projects, I would say. And so, it's this whole big thing, and they're like, well, there's this smart contract component of it. And there's enough programming languages research stuff about smart contracts that I had been aware of Solidity and, the EVM and these hacks and vulnerabilities, done my share of eye rolling. Like the design of this stuff is horrible. It's not going to work very well. But I never really thought about like, that's a problem that I should work on because Facebook didn't have any code in that area.
When were you looking at that? See, I rolled my eye on that. So it means like you're looking at that stuff on the side for fun.
Yeah, for fun. Well, yeah, I guess as a researcher, there are a couple of big conferences in your field. And so you'll read through like the paper titles and the abstracts and then maybe even the papers themselves of what's going on. And so like a couple of years earlier, I guess not so many years earlier because Ethereum came out when like 2016, there started to be these papers about like smart contracts and like, vulnerabilities and like Solidity and things like that. So, just like I would follow any happenings in the field, I read about those. And so I had awareness of it at that level. Like from the perspective of a programming languages researcher, like here's this new class of languages that are emerging, what's going on with them. So I was aware like that, but just like I'm aware about, languages for programming with quantum computers or, other things that the field is interested in. It's very broad in that way. And so when I heard about this, like, oh, Facebook's actually interested in doing something with that. We don't have any experts in this. I see that there's some motivation for doing better here. I have my own opinions about software safety and languages and bugs from my own work at Facebook, my own academic background. Like, this sounds like an amazing opportunity. Like, you might get to design a programming language as someone who spent their career studying programming languages. Like, this is amazingly exciting. Like, very clear to me that this is something that you should say yes to. So I basically dived in and learned about cryptocurrency that way. Like, I started in my domain as learning about smart contracts, and that's where the idea for Move came from. And then I got deeper into cryptocurrency by, working with integrating Move into the Libra project, seeing what other parts of, learning about the other technical parts of crypto, distributed systems, cryptography, and, meeting people who are experts in those and, were willing to share their expertise. This Libra project was an amazingly interdisciplinary and just like clever and friendly group of people that, we're all trying to figure this thing out together.
Let's try to get like really more practical here. So first, what was exactly Libra? And then if you can explain us what problems you're trying to solve and which is why you had to create Move, right? A new programming language.
Yeah, so Libra was a few different parts. So Libra was this blockchain, and the purpose of this blockchain was a settlement layer for payments. And then there was going to be a stable coin, also called Libra, issued on top of the platform. This global currency that can be used for international payments, that's pegged to the dollar, pegged to a value of currency, so that it doesn't fluctuate like cryptocurrencies at the time and cryptocurrencies of today do. And then there's a vision of having companies like Facebook, like some humanitarian or organizations like Mercy Corps, having wallets that built on top of Libra and then facilitated these payments. These are basically organizations who need cross-border payments for what they do as part of their core business. This was the so-called Libra Association. So those were the different parts. And then my domain was both in, with Libra, we want it to be programmable with smart contracts. And so it was my job to figure out, what virtual machine programming language should we use, and how does it fit in with the rest of the system? And then that ended up also dictating a lot of the other parts of the design of Libra. So that's the big picture of what Libra was and how these things fit together.
What were the main problems to solve?
Yeah.
If you look at what you did is you studied Bitcoin and Ethereum ecosystems and the problems that happened there. And then essentially you said, hey, like we cannot have this happening. And therefore we probably can't use the same stack.
Yeah, that's a great question. So with a programming language, it's so interesting, right? With any programming language, you might ask like, what is the problem this programming language is solving? And someone would tell you something, but then you would move on to another programming language and say, well, what about this one? What problems is it trying to solve? And they probably could tell you like some of the similar things. And you go like, what's going on, man? Like, why do we need so many different programming languages? Like, why don't we just have one programming language that does everything super well? And we'll like work on that and we'll have it. Everyone will work on that and have it do it the best. And so I think like the thing with programming languages is that they're, from my point of view, domain-specific problem-solving tools. And so like they should have, I don't think they always do, but I think they really should have a very specific set of problems that they're trying to solve. And they should be like laser focused on solving those problems and focus specifically on not trying to do anything else. Because otherwise you get this mess of, you start off with a goal, you're on the goal, but then, oh, someone asked for a feature, you add that feature. Oh, someone wants to do this, you add that. And all of a sudden you have this mess that, you lose focus and you lose simplicity and, you can't do the core thing. So with Move, like I actually did like want to really start off with having a clear set of problems to solve. And so those problems were, you want a representation of money or of things that are inherently scarce. You want to have something that one person has it and it exists in only that place. And then obviously you don't want it to be copied or copyable. And so this is hard because in a conventional programming language, if I say like, let x equal 7, and I say let y equals x, you're actually copying the contents of x. Well, if x is money, like that's not going to do. It can't be copyable. It has to, have this inherent scarcity. And then also you want transferability. Like I have x, I move x to Kevin. Now Kevin has x, it no longer exists here. I shouldn't be able to continue writing to it or using it or anything like that. So scarcity, like a first-class representation of scarcity in assets was one goal. And then the other goal is about access control. There's the nouns in the sentence, the assets, then there's the prepositional phrases, owned by Kevin, owned by so-and-so, not usable until this time, until that time. These rules on who's allowed to access assets and what they can do with them. And to me, like from studying smart contracts, like this is basically all that they do. It's recipes for creating new assets, what they are, what data is inside them, rules for transferring them, rules for authenticating the people that own them. And so this is a very narrow set of problems to solve, whereas like with a conventional programming language, you want to talk to the disk, you want to talk to the network, you're spinning multiple threads and doing stuff in parallel. You're doing very sophisticated math with floating point numbers. And so the thing that Move is trying to do is do only those things and do those things really, really well, and don't try to do anything else.
You're the creator of the Move language. How would you explain the Move language to your mom in one sentence?
It's a language for programming with money. I think that's the one sentencer.
You studied Bitcoin and Ethereum. We talked the other day about the DAO hack, especially those failures or bad moments in both ecosystems. What specific failures or hard moments in the Bitcoin and Ethereum ecosystems were highly influential in the creation of the Move language?
Yeah, so I think the DAO hack would probably be number one. There's also the parity hack, which happened around the same time. And so there are these big picture vulnerabilities, which I think, it's good to look at those, but you don't want to over-index on just one thing. To me, it's really about looking at the code people write day to day. Even when that code is correct, just where is it not perfect instead of having in terms of having a really minimal gap between what the programmer was trying to do and what they had to write down to do it. And so it's about like having the right abstractions, the right building blocks to do what they're trying to do. And the thing that really struck me about Bitcoin and Ethereum is you read this code and like what it's trying to do is all about this notion of assets and exchange. Yet these languages have no primitives for assets and no primitives for exchange. Like all of these things the programmer has to rebuild from scratch every time. Everyone does it in a slightly different way. Sometimes they get it wrong. And so with Move, what I really wanted to do is figure out what those right building blocks were, and then have the language provide them in a way that's just built in, that's as safe as possible, that's really easy to work with and stack together to build more complex things. And so I think like there have been many, many more of these security incidents in Ethereum since then that are motivated. But I think like any of these, when you look at them, I think it usually goes back to someone did something wrong because they were trying to do something complicated that should have been simple if you were starting from the right building blocks.
Most programmers use programming languages to build applications. They're using languages that exist already.
Yeah.
How the hell do you create a new language?
Yeah, I mean...
Where do you even start?
That was a very daunting thing for me, because I think the way most people start is they take an existing language that they kind of like, and then like maybe there's one or two things that they don't like about it, and then they sort of like change those things, and they say, look, it's a new language. But, you really... It's such a hard problem, right? Because with languages, even if you figure out what to do and it's 10x better than everything else that's there, like adoption and community are such a huge deal. Like having the existing documentation, the answers on Stack Overflow, the army of programmers already know your language and can go and work for companies. the tooling, IDE integrations, compilers today, like LLMs that understand it, all this kind of stuff. It takes so much time to build out that you should probably just abandon the project and not not design a new language in the first place. And so the first thing we try to do is not set out to build a new language. Like, let's see if we can take the EVM and make it better. Let's see if we can repurpose WASM or the EVM, let's see if we can repurpose a general purpose programming language like the EVM or the CLR or WASM or these sorts of things. I think like that's always the approach you should take. Like, see if you can solve your problem with something that's there, but add modifications on top or add some restrictions or like change it to be what you want it to be. And the reason we didn't end up going that route was when we looked at general purpose languages, they just tried to do so many things. Like we were talking earlier, like, multi-threaded programming, disk IO, networks, fancy math and all this. Like, to get it to be a smart contract language, you ended up having to restrict all this stuff that you don't need and then add, asset support and, account support and transfers and all this stuff on top. And it ends up looking like this chimera of like delete a lot of the stuff and then add all this new stuff. And it's not small and simple and very problem directed. And so I think like, if you see Rust and the way like, Solana uses Rust, it sort of looks like this too, where like they have to take out some features and they have to add their own like sort of Solana specific abstractions and libraries. So like, let's try to do exactly what we want. So the way I approach to actually answer the question, the way I approach designing language is figure out the problems to be solved, the jobs to be done, having these nice abstractions for assets and access control, and then build out a language that what's what I would want as a programmer if those were the things I was working with, and what's sort of the absolute minimal set for that. And then just sort of start writing a bunch of example programs of things we had seen in Ethereum and, make sure we can implement all of them, that they look really nice and they look really simple and sort of seem like the essence of what you'd be trying to say. That's how I approached it, but I definitely had a lot of blank sheet of paper shock during this time. And, I was like, ooh, yeah, I don't really know how to get started or like whether you're going down the right path or any of these sorts of things.
I had Gavin Wood on the podcast, the inventor of the EVM and the Solidity language, which is most likely one of the reasons why we're both here today. And as you came up with the Move language, which is a sort of next evolution of the Solidity language, I have to ask you the same question as I asked him. How do you come up with a great idea?
So to me, great ideas are great because they solve important problems. And so I think like it's always about being the really, really problem directed and like, following the so-called Feynman methodology where it's like write the problem down, like think very hard and solve the problem. So I think like if you really understand the problem that you're trying to tackle and like you understand why it's painful, you understand the different parts of it, you understand different approaches that have been taken. I think once you've really done all that work, usually the solution or idea is like almost the easy part. It's like it comes from that deep understanding. So to me, like I think almost all of my good ideas have come from just like really trying to get it. Like why is this so hard though? And just like maybe being more persistent and more curious than other people are in that part. Whereas I think a lot of times it's just like people want to start with the blank slate thing or the thing that I'm doing uniquely, and it's really easy to lose track of why you're doing it and how it ties back to what you're trying to do. So definitely, some people working with me on the technical side probably find me annoying because I do what my PhD advisor used to do, which is like needs more examples, like need to understand the pain of this better, show me why this matters or like that this addresses everything, and like insisting on that before going into the solution phase.
That's actually a very good framework or way to approach business building, right? Because one of the biggest problems in tech, in crypto, is people who are building solutions to problems that don't exist. I'm building a solution, but there's no problem out there.
Yeah. It's 100% true, right? Like the original sin of the crypto space is that you have one slam dunk use case, which is speculation, and it clouds product market fit. So, people think they're act like they're trying to solve one problem or think they're trying to solve one problem, but then it's clouded by this other thing going on. And so I think in the crypto space is especially hard and especially important to really be problem focused and to do things because you're making progress on the problem, not because of some side signal that you weren't going after or that other people are pushing you to do with these sorts of things. So yeah, it's an especially big challenge here, I would say.
So focus on the problem even more and understand the problem and understand why the problem is so hard.
Yeah, exactly. And why other things haven't worked. Because if you don't understand how other people approached it, you'll probably end up doing the same thing or doing like an incremental version of what someone else has done. And so I think, for me, creativity comes from understanding it deeply enough to be like, but no one's poked at this facet yet, or like they tried this, but maybe they thought of that. The really the touching on the sides of the elephant or whatever the right metaphor is.
How do you avoid paralysis by analysis? For example, in the example of Facebook, they probably told you, okay, we need you define if we need a new programming language or not for that.
Yep.
But we need to ship.
Yeah.
Hey, we have a deadline. We want to get this out there. It ended up not working out, but you have time constraints, probably budget constraints. So you can't just analyze everything forever.
Yeah, totally. And I think you could easily spend 7 years designing a new programming language if you didn't have these sorts of constraints. So I think having deadlines helps. I think having deadlines is basically the only way to do it. And then I think there it's like, figuring out, because I have this deadline. With Libra, we had just enough time to take the bold move of designing a new language. If it's like you have 1 month, it's like, okay, you're going to use the EVM or, something else that's there. If you have 2 or 3 months, maybe you could try to retrofit an existing programming language. If you have 6, well, you could do something new, but you better get started soon and you better have an approach for doing it incrementally. So, for me, I was like, okay, I know the first thing people are going to ask is how do you represent coins and do coin transfer. So I make sure I built out that part of the language first and had sort of sketches for the other bits, but maybe we didn't have to have them implemented yet. Or, we would still have flexibility in the design from what we learned in the first part. So I avoided by trying to avoid analysis paralysis by having an idea of the big picture of what we're trying to do, but then always trying to plan out incremental steps where not only can I make progress incrementally, but I learn a lot from the first things that I do and have the flexibility to change things later on. You always want to downscope the problem to sort of the minimal thing where you can, try it out and get feedback, whether it's from you or from users or from other people looking at the design or whatever else. The most risky projects are the one where someone goes alone and does something for 6 months without asking for feedback and then comes out. It's really scary for them coming out of that room that they might have wasted time.
But you also feel safer along the journey, right? You're just there in your room, you're doing your thing. So you don't feel like you're too much at risk.
Yeah. And I think that's why some people why there's a tendency to operate in that model. There's a thing from Google X that I think about a lot that I think makes a lot of sense and that is like against human nature to do, but it's like so important, where it's like, if you want to have a monkey stand on a pedestal and recite the works of Shakespeare, you do the monkey first. You don't spend all the time building the pedestal and making it the most beautiful pedestal and making sure that the monkey can be in front of the microphone and stuff. It's like you do the part that's most likely to fail first, the riskiest part. And like, even though like as a person you want your project to keep going, it's like you really got to go after like the hardest and riskiest bits first, but then also get incremental progress on them. So I try to think about that principle a lot. And
this is a very entrepreneurial way of seeing things, right? And it's necessary in startups, but it's probably not the most natural way to think for an engineer.
Yeah, I mean, for an engineer, I think it depends. I think a lot of projects just don't have that. Either they don't have that much risk to them, or most dangerously, you think that the project doesn't have that much risk to it, and so you just approach it wherever, doing the parts that are most interesting first. But I think like even as an engineer with something that seems straightforward, I mean, you see it with sort of government software projects or these sorts of things where they're large. It's like there's anything with software has a lot of inherent complexity and there's going to be risks. And so I think like engineering should be approached this way too. Like really try to figure out what the hard parts are going to be, see how much you can get a handle on that early. But nobody wants to fail, and somehow it feels better to be a zombie for a long time than to like fail right at the beginning. But if you have limited time, you really want to do that. And we all have limited time, right?
You mentioned before, started with a lot of blank piece of paper. We talked about a concept called unstructured thinking the other day that you like to use. What is that?
Yeah, so for me, I talked about my path as an athlete, like running is the thing I grew up doing like in high school and college, and still do a lot of today. And so I'm spending a lot of time every day. I think probably more time than most people without having a phone or headphones or being in front of a computer or talking to other people, but just like running around and you run the same routes or similar routes every day, and your mind drifts where it will. And a lot of times I end up
You run every day.
like 6 days a week or so. sometimes 7, but 5 or 6. So yeah, it's not like I run out and be like, okay, today I'm gonna solve this problem on the run, but you're running and then like there's a song playing in your head and you see a bird or a tree or you cross the street or see somebody and then like something will pop up to like a little corner of like something you were thinking about, or you'll be trying to think hard about something. You'll be like, but wait, why was I thinking about that thing? Like, zoom out, like what's the purpose of that? Like, why not do it this way? And so I feel like I end up solving a lot of problems or making a lot of progress on technical problems, business problems, like personal problems from having that time, every unstructured time of thinking and reflection every day. I think other people get to the same or similar place via, meditation or some other thing. But for me, it's like that practice of running, even though like I don't do it for that reason, like I definitely find that that's some of the most productive time of my day.
There's a book called Psycho-Cybernetics that talks about something similar, right? It's more you have a problem, you envision the goal, and then you just let your subconscious, because it's probably 95% of what happens in there, do the work.
Psycho-cybernetics, I like that term. I'm going to use that now to describe what happens on the runs instead of unstructured thinking. It's a lot cooler sounding.
It's what happens in your subconscious mind, right? Which is always solving problems, even when you sleep or you're just doing things without realizing.
Absolutely.
Why does unstructured thinking work so well?
I think it works well because, it's just so easy to get in a rut or fall into a pattern or sort of like a loop when you're trying to do something. And so I think it works because like you're not forcing yourself to do it. It's sort of like the unconscious, like as you're saying, it comes up unprompted, and because you don't have distractions. I think that's maybe even the most important thing. This is a problem for all of us, and it's just getting worse all the time. Like there's so much stimulation and distractions like in your pocket on the screen in front of you, like how many like tabs and windows and and we live busy lives with families and friends and all these sorts of things, and this stuff is wonderful, but there's not a lot of time you have to focus on just one thing. And it might sound a little weird to say like I'm focusing on just one thing while you're like running around, but that's the thing about running a route that you do all the time, where it's like there's sort of an autopilot. I don't think about where I'm going, and it's like very comfortable because it's like a pace that I'm used to and a distance, and then so it really is just like freeing your mind to do that one thing. I think that's why it works, but it's hard to know.
What types of problems are best solved with unstructured thinking?
Hard ones. But more specifically, I think something where you either need a reframing, like you're like, I'm really in the weeds of trying to do this specific thing, but really you're like misguided in trying to do this specific thing. And if you like step back and ask why, you realize you should be trying to do this other thing instead. Or I think things where you need to connect ideas or solutions from disparate areas. Like for me, and this is with the research problems, like I was mentioning before, like in these conferences, like when you're a researcher, you have the big conferences and you read the titles and abstracts of all the papers that come out. And there's like many papers that you've read in your lives across these very different topics and ideas. So sometimes you'll be thinking about something and you'll be like, I feel like I've heard something similar to this before, but like I don't really know what it is. And then you'll see like, oh, it's weird. Like this person working on this quantum programming language had this unique feature that I didn't really think about as relevant to this problem because I'm here working on a smart contract programming language. But I see like the thing I'm running into is actually something that they did. So maybe I should go back and look at that paper, or it'll just jog my memory of what that was. And then, you go and you make that happen. So I think those are some of the modes that are the most effective.
So this unstructured thinking helped you build the Move language,
Definitely,
which is used by Sui, but not only.
Yeah, Move is growing.
Move is growing. There's a new generation of layer ones like Aptos, Movement, that use your creation, the Move language. How do you feel about brand new protocols that are worth billions of dollars and built using the language that you created?
I feel great about it. I mean, this was always the vision for Move, where, we think that Move is a better way of writing smart contracts. We think it's a safer way. I think that smart contract safety is one of the key things that's holding back broader adoption of crypto and that's stopping crypto platform growth. So, I want to see as many platforms as possible using it. I mean, with Sui, like we have the team that worked on the Move language here. I think we're the ones that are driving it forward and sort of setting what happens. But like I always love every new platform that uses Move, and I think if everyone used Move and there was no more solidity in the EVM, that would be net good for the space. I'm obviously very biased in this, but I feel proud when there's new platforms using it for sure.
Why is the Move language the best programming language out there to build any blockchain application?
because safety is the most important thing about smart contracts and Move is the safest language. I think it's really as simple as that. And then, so I think that's like the big picture sort of like business for a CTO pitch. But then I think for a programmer, they like it because they try it and they're like, oh, this understands what I'm trying to do. I can be more productive with this. I can focus more on the business logic and less on low level details and not worry as much about security. I think they really feel like it was made for them and it understands them and it's sort of a good thought partner. That's what developers tell me anyway, and also what we shoot for.
You're the co-founder and CTO of Mysten Labs, company behind the Sui Network. What is the Sui Network if you had to explain it to your mom?
Yeah, so I'd say the Sui Network is an experimental developer platform. Think of the iOS App Store in the early days when people didn't know what to do with mobile apps, so they built like an app that you press a button and it farts or something. That's the stage we're at for for smart contracts today. But then it's like, oh, there's really a lot of potential here in terms of what people can do with this, the problems they can solve, and there's a lot of interesting experimentation going on with people putting stuff out there and seeing what works and what doesn't work. And for us as the platform developers, figuring out what else people need. I think that's how I'd explain it.
Why is Sui the best layer one blockchain out there, out of the sea of layer ones that we have emerged in the crypto industry over the past few years?
Yeah, I think it's the best because it's the best for developers. So I think first of all, it's the fastest. Like end users care about that. Developers care about that. I mean, the fastest in terms of the time it takes end to end to send a request and get back a response. I think it's the fastest to get started as a developer and sort of the fastest to get started, the fastest to iterate and to do things the safest. And I think it provides the most features and components of the stack end to end. Like, with Walrus, which is one of our big focuses right now, like in any conventional application building, right? Like you have your disk, you have RAM, you have RAM, and you have CPU. And with other blockchains, I think you only have RAM and CPU and there's no disk. And if you think about what applications you can build if you don't have a disk, like a lot of things are going to be off the table, right? Like, you can build a calculator, but you can't build a machine learning model. You can't build, almost anything on your phone. Like everything needs persistent storage. So that's really one of the things we're trying to differentiate on is like, in addition to, yes, the speed, yes, the developer experience, yes, the scalability, it's just like fundamentally different capabilities that you need as an application builder trying to build a rich app that is trying to, do real things and provide real value.
You mentioned decentralized data storage. My question is, what's possible on Sui that is just not possible on other blockchain ecosystems?
Yeah. So I think with Walrus, anything where you want to pay for the creation or consumption of data from a smart contract, which I think is an extremely fundamental thing for.
Can you give a concrete example?
Sure. Yeah.
For normal people to understand, hey, why do we need this?
Yeah. So say I'm a blogger, I'm creating a Substack-like blog platform. I'm creating a blog post and I want people to be able to subscribe and then to pay me, and they should only be able to access the content if they pay me. So I think in order to do that, you need in a Web3-like platform, you need a surprising number of things. You need the identity and the payment rails. That's the layer one. You need to be able to store the posts. That's Walrus. You need to be able to encrypt the posts. That's this forthcoming thing that we're working on top of Walrus. And then you need to be able to say, when I exchange the money, then that person should get access to the post, but they shouldn't get access to it beforehand. And then also, it's not like that person should be able to get access to everything I've ever done. They're paying for this post specifically. So that's a lot of different moving parts. I think like a lot of people can do the identity and the payment part, but they don't have the attached storage layer. They don't have the encryption, and they definitely don't have this exchange of like, oh, configure the access control policy for the storage on the layer one.
This is like what we call row-level security, like the security of the different what people can access.
Sorry, what security?
The people who are allowed to access certain things.
Yes, yeah, access control policies we would call that, or that's one term. Yeah.
We talked about energy management yesterday.
Yeah.
So obviously you are on this Sui journey. I mean, not only Sui, but Mysten Labs journey. This is a multi-year, if not multi-decade journey.
Yep.
You're the CTO of a company that raised hundreds of millions of dollars. There's a lot of pressure. You don't look like you are stressed out. You look pretty chill. there's a lot of pressure nonstop and it's a long journey. How do you keep your energy and enthusiasm during a very intense journey that lasts years, if not decades?
Yeah, so I think you're right. I think I'm not stressed. You got to have fun, right? And I think this is a really fun place to work and a really fun industry to be working in. I think it's all about like, making sure that you're doing things that you find enjoyable, that are fun, but that are also really important for the industry and for the ecosystem. And I think for me, I mentioned like the way I am as a person is that I'm very curious. I like doing a lot of different things. I'm very experimental. So I'm like pretty happy doing a wide range of tasks. But like for anybody, including myself, like there are many aspects of running a business or doing things where it's going to drain your energy and it won't be the thing that you like the most. And like as you scale and grow, there's going to be enough of those things. You could easily fill your day doing all of those things. And if you do that, you will not be a very happy person. And some days that might be the most important thing for the business and you just eat it and go for it. But in the long term, like you're going to burn out if you do that or you're not going to be happy. So I think it's all about just figuring out that right portfolio of things to do. And I mean, maybe even more generally, the way I came up in my career is like, you're an IC, you're working on some coding project or software project, you have some list of things you want to get done for the day. I write at the beginning of the day, I burn through that list, I'm done in the afternoon, then I go do more. And, I feel very happy with myself because I've like met my expectations and exceeded them. When you're running a company, it's not like that. Maybe it starts off like that and I still start off my day writing off what I want to do. But then the way it works is like, you have the intention for what you want to do, then something comes in and it's very important, or then there are always these sort of distractions, or the things you want to do are very long term, so you can't finish them in one day. So you have to learn how to be satisfied with.
How do you do that? How do you do that? It's so tricky. Like the ultimate for an employee, the ultimate example is maybe working in business development or sales.
Yeah,
because the sales cycle are very long, right?
Yeah.
So the kind of joke is always, once I close this deal, I'm not even happy anymore because it took so long, right?
Right.
But when you build a business, it's this, but on another level. And so it's very easy to basically never really be happy because there's no small things to celebrate.
Yeah.
How do you do that?
Yeah, well, you have to figure out how to incrementalize your goals and then take satisfaction in incrementalizing them. And, for me, it's like, because there are just so many things that happen, you never get to all the things you really should get to in a day. You have to learn to take satisfaction in dropping the right balls instead of not dropping any balls. And I think that was a personal transformation I think took a while as Mysten got from being small to like being a little bit bigger. But I think now I'm very at peace with it, especially recognizing that other people don't and can't expect you to deal with everything that they try to put on their plate. They, as employees in the ecosystem, like they want you to be focusing on what's most important. So they're not going to be upset if you don't get to their thing or you pick something else. Like they trust you as a leader to do the right thing. So I just try to trust myself and be worthy of other people's trust to do that while also keeping my energy high.
How did you learn that? Just learning by doing?
Trial by fire, yeah. But I think also look like I've had a lot of like really excellent mentors. Through my career at Facebook, I mentioned my parents too. Like I think my dad has always been very much of like picking work that you find enjoyable, so it doesn't actually feel like you're working. And he follows that example himself. He retired and then he recently like unretired to go back to work one day a week. He's a cardiologist because he loves that so much. Or one of my mentors at Facebook, this guy Peter Ahern, is a researcher. He always encouraged me, as a software developer, like who's with a research background, like, yeah, you could do this development stuff all day, but you have to pick this portfolio of projects that are going to have impact for the company and advance your career versus stuff you're interested in. And a lot of times those end up intersecting in ways you don't expect. So I think both of those things are things that I think about and helped, but it was a lot of trial by fire from just doing it and having to deal with a company that's growing and being successful.
How much of what you do today is on the bucket of I love it, and how much is on the bucket of I have to do it?
I think it's like 90-10 on a typical day. I mean, I'd say it's very high variance. I think there's a lot of days where I'm like, everything I did today, I loved and it was awesome. And I don't even want to go to bed because this was so great. And then there are some days where it's like, wow, like this was one of those days where I just got to burn down a lot of not so pleasant tasks. And that it's not great. But I think, even things that I don't get, I think like crises or stressful situations, you can always find humor in them, or you can focus more on like trying to help other people be calm and de-stress. And like, I think that's something I do well. So that part, it's more of just like when you have tasks that are the grind, like I've agreed to produce this artifact and like, I'm excited about doing it, but I just don't want to have to do it on this deadline that is still can still be hard sometimes. But no, I think my average day is like super high satisfaction tasks for the most part.
Maybe it's because also of your hobby that you developed in the last 5 years, surfing. That makes you even better.
Yeah.
So you said 90% of what I do is amazing, 10% not that good. You add the surfing on the side, like you're at 120% of pure happiness.
Yes, exactly. And surfing is kind of like the opposite in terms of the distribution, where like the activity is like 99% paddling around and getting tossed underwater and, you know, waiting, and then like 1% of like the best possible feelings. So maybe having that reversed ratio and like high variance also contributes. But yeah, it's something I've really gotten into, and my wife also does it, and you know, so it's a great thing for us to do together. And it's just it's just incredibly fun, incredibly relaxing, just like a great way to like explore nature and like, you know, guide your travel. And it's like people who haven't tried it should really try it. I feel people say like, oh, like the water's cold or there are sharks or things like that, but man, it's so worth it.
You said surfing makes me think a lot.
Yeah.
Why?
Yeah, I mean, it's a different, you know, talked about the unstructured thinking with running. I feel like surfing is a little bit different, where you can't let your mind completely untethered and like, you know, sort of autopilot like I talked about, because you're going to end up on the bottom. But it is like you're very focused, but not in like like, you know, okay, look for the wave, make sure I'm in a good situation, like get set up, but not in a like scared or like high stress way kind of. So I think and then there's this emotional variance of the, you know, riding a wave and feeling super happy about it versus, you know, trying not to get held underwater. And so it's like, yeah, thoughts more like pop up in the time in the spots between the intensity that's characteristic of the activity. I guess that's how I'd explain it. Surfers are famous for not being articulate and, you know, going dude and bro and tube and stuff. And I feel like I'm doing that now, except with the thought patterns. So I apologize for that.
As long as you don't do that in the office. When you get out, hey dude, hey bro. What's something that you believe in that most people would not agree with?
Yeah, let's see. What do I believe in? That won't get me in trouble, or you know, I guess it's fun to get in trouble a little bit. I guess I these are maybe boring or nerdy opinions, but whatever. It's something I believe strongly. So you know, this is also a software thing, but not about smart contracts, where there's this notion of memory safety in programming languages. You know, so languages like C and C++ don't have memory safety, and then like more modern languages like your Rust or your Java or something would. And there's this interesting. Sorry, this is really nerdy, but we're gonna do it.
What is memory safety?
Yeah. So memory safety is a property of where things have a clearly defined boundary, and like, you know, the data sits inside the boundary and programs aren't allowed to go outside of it. So a classic example might be like, you know, there's a list, you know, you have, say, a contact list, and like you're allowed to look at yourself in the contact list, but you're not allowed to read outside to see who others people's contacts are, that sort of thing. And so if you have memory safe languages, it's very easy to ensure these properties. And if you have memory unsafe languages, you can, but you have to do it very carefully. And if you get it wrong, the consequences are very bad. So most software vulnerabilities outside of the smart contract space have led from using these memory unsafe languages, and, you know, people thinking they can get it right and getting it wrong, and then like costing definitely, I think, tens of billions or trillions of dollars at this point. And so I think like from a regulatory perspective, we should do more about programming language safety, because it's one of these things where you're using this tool that we think people can be careful and get it right, but they don't. And when they get it wrong, everybody's like, it's not just the programmer or the company that suffers. It can be like the Equifax hack. You know, this happens because like someone uses a memory unsafe language. Hackers get onto the machine, and then they can do more with that access than they should be able to. So I guess my unpopular opinion, or something that most people don't think, is I actually think there should be more regulations about language safety and not using these things that have been that we know after many years are just not quite safe.
2 questions. What was the Equifax hack, and what was the result of that?
Yeah. So
and just the other question is, are the people who should make these decisions qualified enough to make these decisions?
Yes.
Which is a big problem. I mean, now it's better with Trump electing David Sachs and all these guys. Basically, it's like Silicon Valley takeover of the government. But otherwise, it's a big problem. We had, I mean, you worked for Facebook. We had so many examples of like Mark Zuckerberg just talking to people who don't understand what the fuck is going on, right?
Yeah.
So what's the Equifax Act? And are the people in the government or the people who are supposed to create these rules qualified to make these decisions?
Yeah, it's a great question. So this was Equifax is one of these credit agencies in the US. Like, they maintain credit scores for people, so they end up having a lot of private information. They had a breach where someone was able to get in and like basically steal lots of people's social security information, credit information, like all of this kind of stuff. And, was due to a variety of factors. But at the end of the day, it's all these sort of hacks always have the same recipe. It's like someone gets access to a machine, then they can do something, and they're able to get access because they exploit a memory safety vulnerability, or because once they get on there, they find one that they can exploit and do something. So that's what that was. And it's like everyone in a credit bureau tracks your credit info, whether you want them to or not. It's like everyone in the country is affected basically by this, even though they didn't write the bad software or sign up to be part of this service for these sorts of things. And that's not the only thing that went wrong, but it's certainly something that aided it. And so the second part of the question, do the people who would make these decisions have the right expertise? That one is hard, because programming languages, like, this is a highly technical thing. I think you have to have people asking the right questions and then like bring in the right experts to do this. And I think the right question to ask in this case is just like, why do we feel like all software is going to be like inherently hackable and unsafe? Like, is that a truth of the universe, or is that just like a state that we've gotten ourselves into by making a bad set of decisions? And what can we do to undo that axiom, basically? And I think if you ask that set of questions, you would end up bringing in experts that might suggest this as one potential mitigation. Or they could have a 20-year certification program to become a software developer that kills all innovation. There's a lot of ways you can do this wrong too. So I'm not suggesting like regulation is an answer for anything. I think, and I guess I shouldn't even say regulation. I think we should be more thoughtful about things that just seem bad and unfortunate, and like how we can actually do it differently with better core technology or better programming language choices in the case of my particular passion area.
Talk about regulation and crypto. What's the right dose of regulation if you don't want to kill potential?
I think the right answer is having some, and I think that's been the problem in the U.S. up to this point, is that there have not been clear regulations for folks that want to operate in this area, and it's more of a regulation by enforcement kind of thing. And I think like that's what needs to change. Is like there need to be guidelines and rules that people know how to follow and to stay within, and those need to be enforced. And I think like that can be a great starting point. So I think like right now folks are talking a lot about stablecoins and stablecoin regulation. I think that's an excellent starting point. As something where there need to be more rules. It's clearly something that has broader utility. It's clearly something a lot of people are operating in with different levels of sort of carefulness. And I think it would be great to codify that more.
What's your biggest prediction for the next 24 months?
Ooh, Sui related, world related, Walrus related.
Anything related?
Anything related. 24 months is a long time, but I think
it's interesting you say that, because usually I say 12 months and I was told this is not long enough.
This is not long enough.
This is too short. So I'm like, okay, I'm going to do something that gives a bit more room for safety.
So I think, I like that technique. So I think in 24 months, if we do our job well, I think the number of developers that there are in crypto today has been like a little bit flat, like around like, 25,000 over like the past couple of years. I think that number will be at least 5x. I think most of those developers will be using Move and Sui. That's my prediction for 24 months.
What do you mean by if we do our job well?
I mean, if we as Mysten Labs execute on our plan.
Can you tell me a bit more about that? How do you get 5x more developers in the crypto space and move them, pun intended, to the Move language?
Yeah. So I think getting non-crypto developers into the crypto space, I think the key thing is showing the value proposition that a platform like Sui can provide without having them have to go all the way in. So, something that we do a lot is we try to have SDKs and APIs, or these programmable transaction blocks, which we can talk about more, for being able to use Sui from the front end. And so I think we should make it easy for people to experiment with crypto-powered utility without having to, make the pivot to be a crypto app or crypto developer, that sort of thing. And then I think once they do that, if you use a little bit of something and see that it's useful, you want to customize it, you want to build on other things, you want to see what else you can do, and that's how you get all the way in. So I think we need to have clear value propositions for what folks outside of crypto should be doing. I want to experiment with doing micropayments or, invoice arbitrage, where instead of billing people monthly, bill per usage. I want to experiment with ownership in my game, and then have nice APIs for those things, get them to try it out. And then, don't sell it as a you should have laser eyes and do this. Just sell it as experiment, see if this provides value for your business, iterate with it, see if it can work, and throw it out if it doesn't. And then just do that at scale, and then show enough utility that you get lots and lots of people in the door. That's the high-level idea.
That's probably where the Sui teams and Mysten Labs teams background in Facebook helps a lot.
Yeah, absolutely. I mean, we know how to build developer platforms. We've worked with apps that serve billions of users. We know how to scale and do growth. We know how to be ambitious. Absolutely. From the founding team and a lot of other folks, this background helps a lot.
Amazing. Thank you so much, Sam, for doing that. Thank you for taking an hour and a half of your already wholesome day to make my day wholesome.
Thanks, Kevin. This is a lot of fun. I generally enjoy the conversation.
Amazing. Thank you so much.